Hello, with the technical difficulties I've been having with my computer lately, I decided to record the notes this way so you can hear me but you cannot see me. I already have the notes filled in because it's really hard for me to write on my trackpad. So I will be revealing them kind of one at a time so you can kind of see where we started, where we're going with all of our numbers. So we're talking about the third way to solve today. So last week we did square roots, and the week before that we did factoring, and then we took a quiz over that on Friday. So now we're going to talk about our third way to solve quadratics, and that basically works when we can't factor and when we can't use square roots. So the big thing to recognize is you have to have your equation in this order, so that way your A, B, and C line up. That way we make sure we put the numbers in the equation exactly like they need to be. It also needs to be equal to 0, so kind of like when we were factoring. So if you need to, you have to rearrange a little bit in order to get ready for you to be able to use the formula. So then our quadratic formula is this. So there are 2 places where you use A, 2 places where you use B, and 1 place where you use C. So the A value is the number that comes with the x squared. Now when you substitute into formula, you do not use the x squared, we just need the number. So we're going to substitute that into the 2 spots, 1 behind the 4 and 1 behind the 2. B gets used twice as well, but again, you just use the B, not the x, so just want the number attached there. We're going to substitute that in for the negative b and the b squared, and then c doesn't have a variable, so just use that as is and plug it into the c value, and that's only used once. I do have a poster in my room, so that way if you don't have to memorize this, you can look at the poster. The other thing I use to kind of help be a fun way to help remember the quadratic formula is there is a little bit of song that I'm going to sing that follows along the beat of Pop Goes the Weasel, and it helps follow the quadratic formula. So here it goes. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So it just gives you a little bit of a fun way to try to remember what the quadratic formula is, because I know it can be long, but it just helps kind of get the different parts in your head. So I'm going to go through it one more time a little bit slower. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's just a little fun thing to help remember, and I'll sing it several times throughout the week of going through the formula. So now we're going to go through several examples. Each example I did specifically so that we could see the different things that are happening, different unique things that might happen with the quadratic formula. You will notice the first example is fairly straightforward. Switch slides. There we go. So our first example is fairly straightforward. So if you notice, our equation's ready for us to go ahead and use the formula. It's equal to 0. We have our terms in order. We have the x squared, then the x, the number. Here's our formula, so that way we can see it as we're going through the example. So what I first like to identify is my a, b, and c in the problem. So the a value comes from the number with x squared and just the number, so a is 3. B is the number with x and just the number, so it's 5. And then c is the plain number, which is 1. So we're going to use those 3 numbers to substitute into our formula. Like I said, this example is fairly straightforward. They're all positive numbers to substitute in, so we don't have to worry about any negatives or positives except for the ones that are already in our formula. So let's go ahead and do our substitution step. So we have negative b. So since 5 is our b, we're going to put that in for our negative b, so it's negative 5. The other thing I always say is it's always opposite what it starts, because if this was 5, like positive 5, notice in the front part of our formula it's negative 5. If b would happen to be negative, then it's going to switch to positive. So it's always opposite what the b value is. So it's negative 5 plus or minus the square root of 5 squared minus and then 4, and then I use parentheses to show the multiplication. I don't always like using the dot because then it kind of looks like a decimal point sometimes. So the parentheses here are just showing the multiplication, 4 times 3 times 1 for the 4AC, and we're going to eventually multiply that all together anyway, all at once, and then it's all over 2A, so all over 2 times 3. So the first thing we're going to focus on is the square root part of the formula. So we really need to be able to take the square root of this number before we can do anything with this other stuff that's in our formula. So that's the first thing we're going to focus on. So we're going to take 5 squared first, which is 25. And then, like I said, the 4AC part, we're just going to multiply that all together. So if you take 4 times 3 times 1, 4 times 3 is 12, times 1 is 12. So there's our next part of our formula. And you can go ahead and multiply the 2 times the 3. So I'm going to make that 6 now. So in this first example, I'm really going step by step to show where the numbers are coming from, where we're going, how we end up there. So usually I combine this step with the next one. So again, the 5 squared came from, the 25 came from the 5 squared, the 12 came from taking it 4 times 3 times 1. So the next thing we need to do is the subtraction so we can get it down to a single number that we can actually take the square root of. So we end up with x equals -5 plus or minus the square root of 13 over 6. So again, our main focus is to get it to this point so we can actually take the square root of 13, which is what we're going to do next. And that's what you'll see here. So the square root of 13, we're going to round to 2 decimal places, is 3.61. So now, like I said last week, and hopefully what you remember, is when we work with quadratics, we typically have 2 solutions. And here's why we have 2 solutions. Because if you remember from our square roots, remember whenever we took the square root, it's always positive and negative the square root. So that's where the plus and minus part of the formula comes from. So we have our plus and minus here. So whenever we took the square root, we need to use both its positive square root and its negative. So what this is asking us to do is solve this out twice. We're going to take -5, we're going to add the square root of 13 and then divide it by 6 to get one solution, and then we're going to take -5, we're going to subtract the square root of 13 and then divide it by 6. So the all over 2a part should always be the very last thing we take care of. So I'm going to write it like this. You don't necessarily have to, but this is where we're going to show our 2 different solutions. So that -1.31 came from taking -5 and adding the 3.61, so that's -1.39, and then I divided it by 6, so I got -0.23. So there's my first solution. So now I'm going to take -5 and I'm going to subtract 3.61, which is -0.61. Then I divide it by 6, so my second answer is -1.44. So that's my 2 solutions. And that's typical what my solutions will look like when you're using the quadratic formula, because for the most part we're going to take values that don't square root nicely. And so we're going to end up working with a decimal here, and so then our answers are going to be decimally. So there's that first solution. So you have -0.323 and -1.44. There's our first example. So then my next examples are going to include some unique things that you did not see in that first example. Like I said, that first example is very straightforward. Those are the typical problems you're going to see. So now let's talk about some of the stranger cases. So this next one is not ready for us to use the formula yet. We do have to get it equal to 0, so I'm going to add the 33 over here so that I can see my a, b, and c from my equation. Again, the a comes from the x squared, the b is with the x, and the c is the constant number. So now I know all 3 values to substitute into my formula, which I'm going to show here. So I have some boxes to cover up so that way I can kind of go step by step. So this next one I'm going to show some shorthand so that way you don't have to rewrite it several times in order to find the solution. I do like showing the substitution steps, that way you make sure that you have the numbers all in the right spots. So that way if you do accidentally put a number in the wrong spot, I know what happened, and so I can grade that accordingly. So I have my -b, so since b was positive, it's -2 here, so we have plus or minus square root of b squared minus 4 times a times c all over 2a. So the next thing I'm going to do, and I have it written off to the side. Sometimes I write it just above the square root. I do that a lot. So I'm going to start solving this out, but I'm going to keep track of my numbers so I make sure that I don't lose anything. So I'm going to solve out 2 squared, which is 4. I'm just going to write that next to it real quick. This is technically still underneath the square root, but that way I don't have to rewrite every single thing a bunch of times. I'm going to just kind of jot some numbers down. So then I keep my subtraction, and then I take 4 times 2 times 33, which is 264. So then now I'm going to rewrite a little bit. So I'll still have my -2 plus or minus, but now instead of the square root of all of this stuff, it's actually going to be the square root of -260. So again, it's still underneath that square root, and that came from these two numbers where we have the b squared minus 4ac part, and then I went ahead and multiplied my 2's together, so that's all over 4. So now we're going to take the square root of -260, which we talked about last week when we introduced the I. Whenever you have a square root of a negative, you do have to change that into an I. So we're going to take the negative off, change it into an I, and take the square root of 260, which is 16.12, and then we keep that I with it to show that it was negative to start with. I took the square root of 260, but I keep the I to show that it is was negative to start with. So I have -2 plus or minus 16.12i over 4. So then I do my 2 solutions. The first one, I'm going to take -2 and add 16.12i and then divide it by 4. Now notice I've went ahead and circled it, or squared it, whatever you want to call that, because if we have -2 that doesn't have an I and the 16.12 that does have an I, we cannot actually add those together because those are not like terms. We like terms in math. So we actually just kind of have to leave it as this fraction, because we can't actually do this addition with -2 and then the 16.12i. So we just leave it like that. So then my second solution, much the same. If I have -2 that doesn't have an I can't subtract that from 16.12 that does have an I, so again I just have to leave it -2 minus 16.12i over 4. So those are my 2 solutions. So with I, it's just one kind of less step because I don't actually have to do that addition and division, because the first number doesn't have an I and the second number does. And I try not to give you a ton of these problems because there's already enough going on with the quadratic formula, but every once in a while you'll see an I show up. So now the next one, again I'm doing several examples because each one's a slightly different. So the next one, again it's not ready for us to solve. We have to take the 16 and subtract it over. And then where the 16x is going to go is right in the middle. So we have x squared minus 16x plus 64 now equals 0. So then I identify my A, B, and C. A is 1, C is -16, B is -16, and C is 64. So I can use all those 3 numbers and substitute them into my formula. So I have 16. The reason why it's 16 here, not -16, because with my formula, b is already negative, it changes to a positive. So it's positive 16 plus or minus the square root of -16 squared minus 4 times 1, or 4 times A, which is 1, times C, which is 64. So then again, I'm going to use some shorthand here to jot these down. So -16 squared is 256. Now, do make sure whenever you square a negative, it should always become a positive. So be careful, because sometimes the calculator doesn't square the negative, but this number you get here always from the b squared portion should be positive. So if you get something that's negative, that means the calculator didn't do it right. So that's 256, and then we take 4 times 1 times 64, and just leave that as a subtraction. 4 times 1 times 64 is also 256. So this is where it's unique, because if you take 256 minus 256, you're going to get 0. Hide these so you don't just see the answer yet. So then the square root of 0 is just 0. So then from there, what you'll notice is something unique kind of happens here. So if I take 16 plus 0, I'm going to get 16, and then divided by 2, I get 8. And then if I take 16 minus 0, I also get 16, and I get 8. So like I said, typically quadratics have 2 solutions, but this case we actually have something called a repeated solution. So we get 8 twice, so it's repeating. So technically this is, you only have 1 solution, and this happens every once in a while. It doesn't happen a ton, but it is possible if you take 1 solution, and that's if you have to take the square root of 0, because whether you take 16 plus 0 or 16 minus 0 and then divide it by 2, you're always going to get 8. So that is the unique thing that happens with that. And so then one last example. Again, we want to make it so that it's ready for us to use the formula, so we have to subtract the 33 over. My handwriting got kind of bad, sorry about that. So we have x squared minus 8x minus 33. So then we identify our a, b, and c. So our a is 1, b is negative 8, c is negative 33. And then we substitute that into our formula. So again, since b was already negative, it becomes positive. We have plus or minus negative 8 squared minus 4 times 1 times negative 33 all over 2 times 1. So this one, it gets a little unique because of some of the negatives positives. So we've already worked with one where b was negative, so that affected us a little bit, making sure that that changed to be a positive on our first part of our formula, and then when you square a negative, it should always become positive. So make sure you watch out for that still. Now the other thing that's negative is c, and so that means that we have a negative behind this subtraction from our formula, and so whenever you have to subtract a negative, you will end up adding. So whenever you have to just watch out if either a or c are negative, that is going to change this sign in here. So we have negative 8 squared, which is 64. And then I'm going to go ahead and reveal both of these. I kept this subtraction, and then 4 times 1 times negative 33 was negative 132. So I kept both negatives to show that with this subtraction and this negative, whenever you subtract a negative, you will end up adding. So you take 64 plus 132, and so that makes 196. So you take the square root of 196, so we get 14. And then, so not all square roots are going to be awful for you. And then we do our 2 solutions. We're going to take 8 plus 14, which is 22, and then divide it by 2, so it's 11. And then take 8 minus 14, which is negative 6, and then divide it by 2, which is negative 3. So not all of your answers are going to be decimals. Sometimes you get whole numbers. Usually you're going to get decimals though. Because a lot of times if we get whole numbers, then we maybe could have factored this one. But we're working with quadratic formula, so I wanted to do some unique things with you. So this one, you just have to watch out for your negatives. Again, the middle part here is usually a subtraction, but again, since we had to subtract a negative, we did end up having to add, and so that will affect our answer all the way through. So hopefully this all made sense. Hopefully it flowed pretty easily, not to be able to see me, but being able to hear me. You do have an exit ticket that's attached to your note packet, so don't forget to do that. It is a yellow note packet or gold note packet, whatever you want to call it. So hopefully all this made sense, and if you have any questions, let me know, and hopefully you're back in class soon. Bye now.